Okay. Thank you for inviting me here. Really excited to talk to you about my job market paper for the upcoming season. And this is a paper on natural resources, the setting being the mountain pine beetle outbreak. Okay, so here's the motivation. Climate change disrupts things. I think we all know this. In particular, disrupts resources and markets for natural resources. What I'm going to study is a kind of climate shock that has caused some sort of change in the nature of the resource itself, and how that interacts with markets for the extraction contracts for these natural resources. So what I'm going to do here is talk to you about this beetle shock, which is kind of an environmentally climate change caused phenomenon that was truly macroeconomic in scope. I'm going to be looking at British Columbia, which is the #1 lumber producing region of Canada. Think about how it affects revenue and delay. So for context, we're thinking about extraction contracts here. Typically, a natural resource owner is the government. So this is a very widespread problem, whether it's oil auctions or what have you. Here in BC timber auctions, the government, as always, is trying to procure these resources or the extraction of these resources from firms. And therefore, they're trying to maximize revenue as always in any auction setting. We also care about other things sometimes in auctions, and here what we care about is delay, specifically because of the nature of the climate shock. What I'll do is use some quasi-experimental variation to measure the effect of an assignment rule for a particular dimension of this climate of the natural resource market. And then I'm going to apply structural techniques to estimate the optimal frontier about the two things we care about, which again are revenue and delay as a function of contract characteristics. So let me talk to you about the beetle itself. My favorite slide. The outbreak was caused by mild winters. Okay, so the mountain pine beetle has always existed in the Rockies of North America and Canada writ large, but it kind of exploded after a series of short and warm winters in a row in the 90s, kind of led its population to break out the epidemic proportions, and it's estimated to have killed about half the merchantable conifer supply of both British Columbia and Canada, actually. So it was a very, very big shock. And what became of interest is something called sanitation logging. So this is much like a pandemic, and in order to control the spread of the beetle, something that became of interest was to actually log trees earlier in order to reduce the impact of the spread and make sure that more and more trees don't get killed. So to kind of convince you of this, here's something that's straight from my data, which is an announcement solicitation for the timber contract here, where it says the objective of the sale is to remove the current mountain pine beetle infestation prior to the 2006 flight. The licensee will be expected to make a reasonable effort to dispose of as much infested lodgepole pine by July. What is reasonable effort? What does expected mean? There's nothing in the entire document that specifies these things, so there are neither sticks nor carrots in place. I interpret this as the government kind of throwing up its hands and saying, we don't know how to fix this problem and make sure that the actual private actor who wins the contract is going to do the thing that we want them to do, which is log earlier. And these images kind of show the beetle itself, for one thing, as well as these kind of gradations of beetle attack that are visible from above that show you different stages of beetle attack as the wood is getting worse and worse. They losing color in its leaves, that's called red attack, and then losing its leaves altogether, that's called gray attack. On the bottom left, if you've ever been to, well, I usually get this talk in the US, I say Home Depot in the US and see some 2x4s and other construction materials, you might have seen some blue stain wood, which are characteristic of beetle attack trees, in which the beetle comes in with a fungi and imparts the blue stain on the wood, which is just a kind of minor sort of aesthetic degradation of the material that doesn't affect its value too much. However, as the tree gets worse and worse in quality over time, it develops checks or cracks in the wood as it dries out. That means that less and less of the volume of the wood can be used to do things like saw boards, which is what you want to get out of these wood logs. And more of it has to be used for low-end products like pulp or chips. Okay, so that's kind of a visual right there. The bottom right was my first time seeing a tree attacked by a beetle in person. So here I'm going to think about economics, right? The three key contract dimensions that you think of are the following, and these are empirically relevant in this setting. The first is the term length, by which I mean the time limit that the government gives to the licensee who wins the contract. If you want the licensee to actually get rid of the wood sooner rather than later, why don't you just give them less time? So again, we're thinking about the mapping of these objects to revenue and delay. We get kind of a guaranteed reduction in delay because mechanically you give them less time. You're going to get less delay. However, it might come at a cost, particularly if you're choosing when to harvest and you're doing this at times when wood prices are good. So housing starts are going on or they're not going on. You might place option value on being able to harvest later rather than sooner, which means that reductions in term length are generally going to be quite costly. That's a trade-off going on there. Second, and this is kind of central, but I'll take some time to explain, is lump sum versus scaled payments. Lump sum is exactly what it sounds like. In a lump sum auction, you're going to pay a fixed amount. The winning bid typically might be something like $1 million, say, for the rights to extract all the wood inside of the tract being sold. Whereas in a scaled payment, it's kind of dollars per quantity or dollars per tree, specifically dollars per cubic meter in this setting. What they do is that they measure as you are harvesting over time, how much wood that you've cut down, and they charge you per the unit. So that's the scaled payment. And what does this do? Well, we think that in auctions, lump sum and scaled contracts work kind of differently. Because if you think about it, the scaled being dollars per unit is a lot like a royalty auction, and that is actually going to have generically different revenue raising properties. Generally, we think higher compared to lump sum auctions, which are a little bit more conventional. However, there's also a trade-off when it comes to delay, and the delay component comes about because these are just different dynamic programs from the perspective of the licensee who has won the auction. So in the lump sum auction, you've already paid everything upfront, and then you can just harvest when you want. There's no additional distortion to your harvesting decision. Whereas in the scaled auction, there's this additional marginal cost term, right? And that's actually going to serve to push the time at which you cut down the trees later rather than sooner. Okay, so now let me talk about the third mechanism, which is that, one second, you might want to adjust the quality, adjust the payments that you pay for worse wood. So I'm saying that there's this stand of forest, not all the trees in there are the same. There's maybe good wood for which you would pay your bid in the scaled auctions. However, for bad wood, you might not cut it down if you had to pay your bid for that tree. So what do? The government has chosen to put administrative fee for these reject logs, which most likely are going to be made up predominantly of pulp and chips in the end. Your question?
So my question is going to be, is the reason that the government wants to stop delay is because they want to maintain the quality of the wood, which is like something that could be internalized by longer, or is it that they want to prevent the spread of the beetle to other trees?
Yes, okay, so
like an externality.
You're thinking about this in the right way. Incentives are aligned when you think about salvage, which is the wood is losing value. So if I, the logger, have won the contract, there's alignment, right, between my private interest and the social benefit of when I cut stuff down. But what makes this problem interesting is that there's actually a spillover spatially, right? There's an externality going on. So that's the main reason that I'm saying that I care about delay. Good question.
Are the stands of wood typically the same age? That the trees were planted all at the same time?
That's generally the case.
But they'll grow it. So you may, is it typically then just a clear felling of that?
Oh yeah, these are entirely clear cutting going on. And BC has been, the BC timber industry has been around for a really, really long time. So some of these trees were planted by the government 50 years ago, even 100 years ago in some cases. Great. Okay, so I was saying that you might have different qualities of trees in a stand, and you might want to make the bidder pay less money for worse trees. Okay, so this is set administratively in the province at 25 cents per cubic meter of tree for these worse quality trees, many of which are those that are going to be in later stages of beetle attack. It's been maybe a couple of years since they were killed by the beetle. If this sounds like a small number, that's because it is. A typical scaled auction bid is going to be somewhere in the neighborhood of 30 Canadian dollars per cubic meter, and 25 cents is kind of pennies compared to that. here's a graph to kind of establish this for you. So take a look, sorry about the lines overlapping, but the blue line at the top and the red line in the middle. The blue line is a sawlog price. We're thinking these are, typical good prices for good wood. Whereas the red is pulpwood price, where you have some logs that didn't quite make the cut for saw logs, and they're going to end up as pulpwood chips. So we can see that there's kind of this gap between these two, as we would expect, but it doesn't look like a proportionate decrease compared to the 30 versus 25 cents that I was telling you about, but rather that just about half of the value is lost going from sawwood to pulpwood. And so this doesn't seem like a particularly well-targeted or well-thought-out pricing scheme here, which would make for a very sweet deal potentially for someone who has pulpwood for one thing, but particularly pulpwood that's killed by the beetle, so that you know that the beetle killed it relatively recently, just maybe midway through its process of decay. And you can kind of see that here in this scaled auction bid, which is the green line, that you can see kind of overlaps a lot with the pulpwood price. If you had to pay your scaled auction bid for that pulpwood, then in some cases it looks like you wouldn't actually do it because it wouldn't be worth it. However, instead you pay 25 cents for that, so that rationalizes why you'd actually cut everything down. Okay, so don't just take that descriptive, at face value, but you can see evidence in the form of these kind of informal regressions with a lot of controls and fixed effects that establishes that things work the way that I'm describing to you. So in the left column, I'm taking a sample of scaled auctions. Actually, let's start on the right column. The right column is the lump sum auctions. It looks like in that column, the more live trees there are, the first row, the bigger the bid is going to be. Not particularly surprising because they're more valuable trees. Green attack is kind of live trees that have gone down in value a bit because they're starting to be attacked by the beetle. So we see a negative coefficient there. Gray attack is kind of already dead. And so we don't actually see any significance there in terms of sign. Contrast that to the scaled auction column to the left. And you see that live share, yes, is positive, it's going to make your winning bid go up. Again, green attack share is going to make your bid go down. But the gray attack share is kind of this intermediate thing of that you're probably going to pay 25 cents per cubic meter of the gray stuff, but it's more recently killed, and we get a positive coefficient on that, which we don't see on the log winning bids of the lump sum options. This holds up if you do full interactions rather than split samples with this whole sample of these two types of auctions. And this is where my last component comes in with regards to these quality adjusted reject payments. So what I'm going to posit is that there's scope for moral hazard, the title of the paper, right? So the idea is that, is it profitable that we have this tree, a shock happened to it, the beetles, its value is changing over time intrinsically. And because we have this discrete fall in what you have to pay for it, once it crosses a sort of quality threshold, is it profitable to move back and delay your harvest sooner, later, in order to take advantage of that and save a lot of money, going from $30 or so to 25 cents per cubic meter for the dead wood, which is still going to be more valuable than the deader rotted wood on the tract. So that's kind of the hypothesis that I want to think about. And let me try to back this up with these sorts of quotes. So this is just me explaining what I just said. I'm going to call moral hazard any additional delay in harvesting activity that comes from tree mortality and the money I expect to save from it. The US and Canada, or the United States, really likes to sue Canada over this trade dispute, longstanding about lumber prices, topical for things going on right now. And right here in the London Court of International Arbitration 2011 was one of the more recent times this came up that has a lot of discussion actually that has directly to do with the beetle. So what I'm going to show you from Canada's statement of defense is that it looks like motive and opportunity existed for moral hazard. What's the motive? This quotation says, when assessing what price to bid for grade 1 and 2, this is the good wood, okay? They put them into two different grades, but they're actually the same in terms of price. Bidders are going to incorporate the value of the grade 4, the dead wood, right? And that stand that actually exceeds the 25 cent price for grade 4. So there's surplus going on from the fact that you're not going to be paying your high bid on all of the wood in the tracks, but just on the good wood. So if you get surplus from the 25-cent stuff, you may want to increase your bid. That's pretty intuitive, I think. Then there's opportunity. Researchers have distinguished early red stage, kind of the intermediate stage of beetle attack, from late red stage beetle attack, and have found little checking, that's cracking developing in the wood, at the early stage and increased likelihood of checking at the late stage. So because the red stage usually takes about a year, this is to suggest that it's kind of rapid within the scope of a few months. And for context, the average timber contract in my data is 1.5 years in length. It can really make a difference if you delay by just a couple months. So that is opportunity. All right, questions so far? Yeah.
I'm slightly confused about the timing of when payments are set. So if you pay, you like bid, and then you pay it based on the quality of the tree at the time at which you're bidding. And so if you delay and the tree gets worse, do they then reevaluate what?
Okay, so in this,
Don't quite understand, sure, but yeah.
right, so lump sum auctions, you pay it all up front.
Yeah.
Scaled auctions, you pay as you go, and they're measuring the quality of the tree as you go. Great. That we clarified that. Okay, so I'll just talk a little bit about relevant literature. Okay, so first, there's a kind of small, but I think growing and very fruitful literature on moral hazard, specifically natural resource auctions. So this body of papers from various authors that look at everything from information design in oil auctions to timing of or rate of extraction in oil auctions, kind of ties together multiple objectives within these auctions that could include revenue, but also other things. So I think that falls very naturally with what I'm doing here. And the moral hazard just generally comes from contract terms are going to dictate how people actually behave once they win the auction, right? There's also literature on just natural resources and the timing of when you extract. These are almost exclusively oil papers, except for Alan Chow's job market paper. And my contribution here, I think, is that the underlying resource is changing over time, rather than this pool of oil that's buried under the ground and is basically static over time. And I forgot to mention that environmental spillovers are what I see as a major innovation going to the moral hazard and natural resource auctions literature. And finally, I know of only one major economics paper, Hannah Druck and Miller's job market paper, on force valuation under environmental shock, specifically from bark beetles. So what she did is that she used the beetles as an instrument for tree mortality and looked at a lot of outcomes, including timber auctions bids, but also things like housing prices and recreational value, in order to put a number on how much do we value trees and forests being alive. And so I want to use this as kind of an input into the valuation of trees in my model. And what I think I have over here is an opportunity to look at policy implications from the sale of the resource rather than just putting a value on them. Do we have a question here? Or, yeah.
Sorry, I'm not able to understand. Are there any other natural resources which behave like this? Is it something which behave like the timber that you're talking about, or is it very specific to this setting and this natural resource?
Yes, okay, I'll start by saying that there are multiple kinds of pests that affect timber, and that the spruce beetle outbreak, which is going on in both Europe and Canada still currently, are examples of that, and those are also kind of functions of climate change, it's believed. Now, apart from just timber, there's pests in agriculture, as well as just changes in the environment in fisheries. I'm not trying to say necessarily that the quality of the resource coming from some sort of warming shock is like necessarily applicable in every single setting, but rather that the resource, the climate-induced shock disrupts some sort of pre-existing institution, such as the timber auctions and the 25-cent thing, which is kind of a legacy that was grandfathered in. And those institutions are not well equipped to deal with those kinds of problems. And you see this come up in fisheries that I'm happy to talk about a bit later offline.
Perhaps related to that, sorry if this was in the first 30 seconds of the list, but how this sort of contract structure, where it seems this non-linearity at the 0.25 is very important, how commonplace or generalizable is that in other contexts. So I understand the nature of the shocks one might expect to have these sort of impacts increasingly with climate change and so on. But as I understand it, your story is coming a lot from this sort of strange institutional quirk at that boundary. Is that the kind of thing we see in other markets like this?
As far as quirks go, this is a pretty big one. The example, I'll go back to the fisheries thing that I was just mentioning, is that we know that there's scarcity created by climate change in different fisheries. I was talking to my friend about this in scallop fisheries in the United States, for example, where they'll do something such as block off part of the fishery from being extracted. And then that leads to other things happening, namely in this case, other regions of the ocean that undergo extensive extraction. So that's more of the sort of thing that I'm thinking about. I think a lot of the motivation for this paper comes from, look, it's reasonable to price good wood and bad wood differently. They took it to the extreme in British Columbia, but that's just an example of an institution that existed before and maybe wasn't optimally designed. Okay, thank you. All right, lump sum and scaled auctions look kind of different. I think in the interest of time, I'll kind of move forward past this. Okay, but auction formats are not assigned randomly. They're assigned according to a threshold rule, and you can see that I'm anticipating some sort of discontinuity design here. So what we do here is exploit the fact that if the beetle kill share, which is at kind of t equals 0, how much of the wood is killed by beetles, if that percentage in a tract goes over 35% in these BC timber auctions, it has to be a lump sum auction. Otherwise, it's usually going to be a scaled auction, but not always. Okay, so here's like what you would call the first stage of the RDD, right? What I do is that I just plot the probability that you're going to be a lump sum auction to the left and to the right of this threshold, and you can see that it really kicks in. To the right, everybody is a lump sum auction. To the left, most people are scaled auctions, 82%, and in fact, some of them are also lump sum, and this is actually likely due to features of those tracts that somehow make the tract unusual to harvest. Helicopter logging would be one, fire damage would be another. Okay. Okay, so let me explain this. So this is going to capture, if we go from the scale to the lump sum and use this as a basis of kind of a half fuzzy, half sharp RD, the effect of going from scaled to lump sum on whatever outcome of interest we want to study. Here, what I'll study is delay, as you may have anticipated. Here I've plotted the bin scatter of the logarithm of the number of delays, which is to say the time in between when you won the auction and when you actually started harvesting. And the gray points to the left are the scaled auctions, the kind of non-compliers or forgetting the word, but the lump sum auctions that are to the left of the threshold are in blue, and the lump sum auctions to the right are all blue. And what we see is this effect of minus 0.91 log points, which translates to 4 months of a difference in delay going from scaled to lump sum. So the takeaway is scaled auctions seem to cause delay. And this is kind of consistent with the moral hazard story that I've been trying to put together for you guys. Okay, some of it, yeah, sure.
Yeah, about the threshold and this measure, can you say more about measurement here? Like who decides and like what institution is measuring, and is there a possibility that there is manipulation around the amount of the percentage that is like the share of beetle attacked trees?
Absolutely. Wouldn't be an RDD without discussion about this. So it's measured by the BC government. They hire foresters to do what's called a cruise. If you read any of these timber auction papers, you know that a cruise is when they take in these forestry professionals and do a really extensive assessment of the timber block and the quantity and quality of trees available and the species breakdown, etc. I've struggled to think about how to answer this question of do they have an incentive to assign it one way or another. We know that in RDDs, precise manipulation is what matters rather than just kind of like random manipulation with some noise added that doesn't necessarily break the RDD. So I think.
But if they know your results, right?
they know the results. Sorry.
Well, I think, I don't know, I haven't seen the end of the paper, right? But if the point is like, it seems in the interest of like social welfare to avoid delays, right? Because you want the sick trees to be cut down and removed as fast as possible, right? I don't know if I understood everything, so maybe, feel free to correct that. But, your paper is gonna show that clearly, the scale options are gonna have a negative, potentially like this negative spillover
Right.
aspect. So in the future, they may be thinking, well, we need to, either change the threshold, the rules, or not change it, but clearly, if there is uncertainty in measurement, maybe there is actually some gain in like having a downward bias,
Yeah,
right? I don't know.
I think I agree with that point largely, and I'm honestly not entirely sure how to answer it at this moment.
Yeah.
I think the better one. So, yeah. 4 minutes. Oh, gosh, okay. Okay. This is the RDP. As I said, it shows you the fact of going from scale to lump sum and vice versa locally. That's consistent with moral hazard, but that's probably not the whole story because what I just told you about scaled auctions and lump sum auctions are just different in terms of their delay properties and their revenue generating properties. What am I going to do? I'm going to estimate a model of bidding in timber auctions. That's kind of the first stage, followed by a model of dynamic harvesting. Think of this as an optimal stopping problem of when do I cut down wood. So why go to this trouble of putting together the model? Well, first of all, I think, as I just said, moral hazard and figuring out how much of it is moral hazard is just something we're interested in here. Second of all, in order to actually trace out the frontier between revenue and delay and what contract characteristics map onto that, as well as whether or not the BC policies as they existed are kind of interior to the frontier or how interior they are rather than being on the frontier are of interest here for characterizing optimal policy. Today, I'll just focus on the harvest stage because the results for the first stage aren't quite finished yet, and I'm still fiddling with the results for the harvest stage. And as I said, it's a optimal stopping problem. Okay, kind of breeze through this. Basically, what I want you to get out of this is that this is a finite horizon dynamic programming problem because we have a term length for these auctions. That means it can be solved with backwards induction, and that the periods remaining n is going to be a state variable. What are the things of interest that I want to capture for the decision to harvest? The first is just the log prices. I know what they are each period, so bigger the log price, more likely I'm going to harvest. Second of all, tree quality, which is evolving over time, which I characterize right now as a kind of deterministic process with a known decay rate for each tract. Okay, and I'm going to control for a bunch of static characteristics of each tract, and I write down a profit function that captures the most important term here, the scaled fees. In the case of a lump sum auction, there are no scaled fees if you harvest because you already paid them up front. In a scaled auction, you're going to pay them, and it's going to weight them according to tree quality, right? It's a weighted average. So everything I said, the 25 cents, etc., is going to be in there. Preliminary results. I use a full solution approach in order to estimate this dynamic program. And what I find so far is that 1/4 of the delay effect, think of this as 1 month out of the 4 of delay coming from lump sum to scaled auctions, is due to moral hazard. Okay. What are the different contract characteristics we want to manipulate, right? So changing the reject stumpage rate for these bad trees from 25 cents in order of magnitude higher, 250, is barely going to do anything to change this result. Further, as I said at the beginning, term reductions are in fact costly. People are thinking about the option value of harvesting wood in the future, even more time rather than less. Okay, this kind of follows from the second bullet point, but lump sum auctions are going to do a lot to decrease delays at low and actually often negative marginal costs. So this to me is very suggestive that the BC policy is operating interior. But in order to really get a good handle on this, I want to emphasize we need to know bidding counterfactuals because once these contract characteristics change, the bidding behavior is going to change and you're somewhere else in the frontier. Okay, so that's in my next steps. I know I got to close right now. That's what I want to do everything that I promised with regards to tracing at the frontier, etc. And then I want to take it one step further by saying, look, I have all these aerial photography data that BC actually nicely compile as shapefiles online. I can take a look at where do I know the beetles are based on the auction tracks in my data and whether or not green attack, i.e. early stage attack trees that probably have beetles in them and see, are they actually located near healthy forests that are as yet unperturbed by the beetle, and think about targeted interventions, and further on, I think a little bit harder about forest valuation measures with the sort of Druckenmiller paper that I mentioned earlier. So with that, I will pause for questions if time, otherwise, thanks. And here's how you reach me.